Yes, my dear students of 10th standard, nowadays we are discussing Unit 11 Carbon and its Compound in our science book, chemistry portion, Unit 11 Carbon and its Compound. Also nowadays we are discussing about the textbook evaluation question answers. The last session we have learned about the short answer questions. There are 5 short answer questions are in your book. Those questions are: name the simple ketone and give the structural formula, classification of a compound based on the pattern of carbon chain, how is ethanoic acid prepared from ethanol, how do detergents cause water pollution, the remedial measures, and differentiate between soaps and detergent. So these 5 answers already we have discussed, and you have to learn thoroughly, and also you have to try to write and practice and get ready for test. Next, see, we are going to discuss about Roman letter 6 long answer questions in your book, page number 171. Long answer question, Roman letter 6. First question: what is called homologous series? Give any 3 of its characteristics. Second question: arrive at systematically the IUPAC name of the compound CH3, CH2, CH2OH. So all these 2 questions answers are in your book itself. When you go to move to page number 159 of your book, you can get the answer for the homologous series. 159. There is 11.4. Here it is explained clearly what is meant by homologous series. Homologous series is a group or class of organic compounds having same general formula and similar chemical properties in which the successive members differ by a CH2 group. So these points you got right. Homologous series, a group or class of organic compounds, a type of organic compounds, a branch of organic compounds having same general formula. So first point, homologous series, a group or class of organic compounds. Second point, having same general formula. Third point, similar chemical properties. Fourth point, the successive members differ by a CH2 group. So when you're going to read bit by bit by understanding the meaning, you can write what is homologous series. Homologous series is a group or class of organic compounds, a kind or type of organic compounds. Second point, same general formula. Third point, similar chemical properties. Fourth point, successive members differ by a CH2 group, CH2 methylene group. So in between 2 compounds of this homologous series, one CH2 group will be the difference. So these are the 4 points you have to mention when you are asked to write what is meant by homologous series. So homologous series is a group or class of organic compounds having same general formula and similar chemical properties in which the successive members differ by a CH2 group. So this first you have to write. Then in the same question also it is asked to write the characteristic properties of homologous series. It is given in 11.4.1. What are the characteristic properties? Question they asked to write any 3, but you have to learn all the points. Sometime you are asked to write all the points, so you have to go through all the points. Then first point, see, each member of the series differs from the preceding or succeeding member by one methylene group, CH2 group, that is a methylene group, and hence by molecular mass of 14 atomic mass unit. So this is already given in the definition of homologous series also. The successive members mean the next compound, or the above compound, the below compound. When you go and check the above compound or below compound, what will be the difference between two compounds? What will be the difference between two compounds? One methylene group, and its atomic mass is 14 AMU. Atomic mass of methylene C, carbon atomic mass 14, hydrogen 1, 2 hydrogens are there. So 2 into 1, 2. So 12 plus 2, 14. That is the 14 atomic mass unit will be the difference between the preceding or succeeding members of the compounds in the homologous series. For example, you can see the left hand side, methane CH4, next compound ethane. See, methane only one carbon, ethane there are two carbons, so one carbon is the difference. And methane hydrogen 4, but ethane hydrogen 6, H3 6. So what will be the difference between 4 and 6? 2. So one carbon is excess, two hydrogens are excess, so CH2 group is the difference. So 14 atomic mass unit is the molecular mass difference between the succeeding or preceding compounds in the homologous series. Similarly, when you take ethane to propane, propane to butane, butane to pentane, also can compare butane to propane from below to above, you can compare. So what it may be, the difference will be one methylene group. Then all members of homologous series contain same element and functional group. So same element and functional group. All members of homologous series contain same element. Same element means a carbon hydrogen, same element, and they are going to have same functional group. If we take alcohol, so all the compounds in the alcohol group going to have OH. We take aldehyde. What is the functional group of aldehyde? CHO. That will be the same functional group in the compounds obtained under the aldehyde. Ketone. We take ketone family. The compounds are going to have CO. That is functional group. Carboxylic acid, COOH. You take ester, COOR, ether, OR. These are the functional group. So compounds of these homologous series contain same element, carbon, hydrogen, and same functional group. Then they are represented by a general molecular formula. Example, alkane CnH2n plus 2. If we take alkene CnH2n, alkyne end with yn is CnH2n minus 2. So these are the three important general formulas. So when you take compounds under a particular homologous series, the compounds are obtained from the same general molecular formula. Alkane CnH2n plus 2, alkene CnH2n, alkyne CnH2n minus 2. Then the members in each homologous series show a regular gradation in their physical properties with respect to their increase in molecular mass. So when you're going to check the physical properties are completely based on the difference in their molecular mass. So when you take methane, ethane, propane, butane, the molecular mass of methane is carbon 12, hydrogen 4, carbon 12, hydrogen 4, 16. So when you go to the ethane, then it's going to be more, you have to add that 12 plus 12. So because of difference in the methylene group. So because of this a change, variation in the molecular mass because of the difference of methylene group. Their physical properties also gradually increase. Physical properties also gradually increase. But when you're going to compare the chemical properties of the members are similar. Chemical properties will not change because of these same elements, same functional group. Physical property change because of the difference in the molecular mass. Then all the members can be prepared by common method. So these are the important characteristic properties of homologous series. So first point, each member of the series differs from the preceding or succeeding member by one methylene group. CH2. So the molecular mass is 14. And a homologous series contains same element of carbon and hydrogen and the same functional group. And same general molecular formula, alkane CnH2n plus 2, alkene CnH2n, alkyne CnH2n minus 2. And the physical properties are gradually changed, vary because of the difference or increase in the molecular mass. But chemical properties are similar. All the members can be prepared by common method. So you have to go through this very simple answer but important answer. And this type of questions are already many time asked in the public question paper. What is meant by homologous series? What is called homologous series? Give characteristic properties. Then second question, arrive at systematically the IUPAC name of the compound CH3, CH2, CH2OH. CH3, CH2, CH2. See, here answer in page number 162. It is given in your textbook. If you move 162, that 11.5.5 IUPAC nomenclature of other classes solved example. First compound. See, first example CH3, CH2, CH2OH. So what we have to do first, we have to, according to the IUPAC rules, first you have to find out the number of carbon atom. There are rules already learned. There are rules. See, in the first rule, what is given? See, first you have to identify the longest carbon chain. From this, we are going to identify the parent hydrocarbon and root word can be obtained. Second, we are going to number the carbon atom and it is closest to the functional group or substituent. It's called a locant number. Then third, you have to find out whether it is alkene, alkyne or alkane, because alkane means when it is saturated. Single bond means alkane, double bond means alkene, triple bond means alkyne. Then if the compound having functional group, and we have to put a dash at the secondary suffix, and primary secondary suffix are joined by the terminal E is removed, then you have to identify the substituent. So these are the 6 rules to be followed to write the IUPAC name. You see, the IUPAC nomenclature of the other classes solved example, the given question CH3, CH2, CH2OH. Here there are 3 carbon, CH3, CH3, CH2, right? CH3, CH2, CH2OH. Here see 3 carbons are here. So the root word is, what is the root word? Probe. 1 carbon means meth, 2 carbon means eth, 3 carbon means probe. So root word is probe because of the 3 carbon. And you have to check what is the functional group or any substituent or functional group, and you have to check whether it is alkane, alkene or alkane. Here all these carbon atoms are bonded having single covalent bond. So single covalent bond. So it is alkane. It is alkane. So what is the parent hydrocarbon? 3 carbon and single covalent saturated compound, that is propane. Propane is the parent hydrocarbon of this compound. And here functional group is there, OH. OH means which is going to refer the alcohol. Alcohol. So propane, and in propane you have to replace E and addition of oil. Replace E, addition of oil. So propanol. Propanol is the name. And OH is attached with the first carbon. So first carbon, you are going to number the carbon atom. You go to start from the carbon having functional group. So carbon having functional group should get the lowest possible local number. So propan 1-ol. So here see, it is given the parent hydrocarbon is pro because of the 3 carbon atom, and so it is going to be propane. Propane. Functional group is OH, so it is an alcohol. So you have to number the carbon, the first carbon having alcohol. So 1-ol, 1-ol. Then root word is propan dash 1-ol, propan 1-ol or propanol, propan 1-ol or propanol. So in this way we have to name the given compound using the IUPAC system. So first we have to find out how many carbon atom. 3 carbon, 2 carbon, 4 carbon means butane. 5 carbon means pentane. So here 3 carbon, it is prop, and it is a saturated compound, so propane. And functional group is OH. So in the propane, replace E, addition of oil, propanol. That is the basic name of this compound. And when you are going to give a local number to the functional group, the functional group is attached with the first carbon. So propan 1-ol, propan 1-ol. In this way we have to name the organic compound using the IUPAC system. So you have to go through these two answers and write and practice in a rough notebook, and you will have test. Prepare well. God bless you. Thank you.